So, in this video, we're going to talk about Gay-Lussac's law. This law is discovered by Joseph Louis Gay-Lussac in 1802. So he repeated the earlier work of uh, what? It
Oh my god, it's not funny.
He repeated the earlier work of Amonton. That's why in some books they call this Amonton's law. This law gives the relationship between pressure and temperature when volume and amount are held constant. Okay, so again, it's pressure and temperature when the volume and the amount of gas are constant. Gay-Lussac found out that if the temperature of a container is increased, the pressure increases. At the same time, when the temperature of a container is decreased, the pressure decreases. With that, we can say that pressure and temperature are directly proportional if and only if the volume and the amount of gas are constant. Okay, so we will have this formula P1 over T1 is equal to P2 over T2. Okay, so since I don't like fractions, let's cross multiply or manipulate this. So we will have this formula P1 T2 is equal to P2 T1. Okay, so again, please mind the subscripts. 1, 2, 2, 1. Temperature must be in Kelvin and not degrees Celsius. So as you can see in this diagram, when the temperature increases, the pressure increases, right? It's because when the temperature increases, there's more kinetic energy. So the gas particles move faster, therefore there are more collisions in the wall. Okay? Now let's try to solve an easy problem first. 10 liters of a gas is found to exert 97.0 kilopascal at 25 degrees Celsius. What would be the required temperature in Celsius to change the pressure to standard pressure? It's very simple. Let's analyze the given. So we have T1, the temperature. So what you want to do is to convert this to Kelvin. Okay, so plus 273.15 equals 298.15 Kelvin. Then we also have P1, right? 97.0 kilopascal. And P2, we have 101.325 kPa. Because again, we want to change the pressure to standard pressure. So it's here, right? Pressure to standard pressure. And now we're looking for T2. So again, we have the formula P1 over T1 is equal to P2 over T2. Cross multiplying it, we will have P1 T2 is equal to P2 T1. Substitute the values or the given. Solving for T2, we'll have P2 T1 over P1. Then just substitute all the values. 101.325 kPa times 298.15 K over 97.0 kPa. So as you can see, the units will cancel, giving us Kelvin. And the final answer is not yet this one.
Are you serious to me right now?
So as you can see, I'm not rounding off yet. It's because we're looking for Celsius. Okay, so what you want to do is to convert Kelvin to Celsius. Do this by subtracting 273.15. This will give us 38.2938, etc., etc. Since the given has three significant figures, our final answer is 38.3 degrees Celsius. Very easy, right?
You know, that's just my opinion. Everybody got an opinion.
Let's have a more challenging problem. So two containers of identical volume are connected by a tube with a stopper to prevent gases inside the tanks from mixing with each other. Container A has a pressure of 2.0 atmospheres and a volume of 10.0 liters, while container B has a pressure of 4.0 atmospheres and a volume of 10.0 liters. Both containers have an initial temperature of 27.0 degrees Celsius and were then heated to 127 degrees Celsius. Upon reaching that temperature, the stopper was released. What is the new pressure in both containers after the stopper was released?
That was a lot.
Okay, so it looks like a complex problem, right? So let's analyze it. Let's start with the given. So it says here we have two identical tanks, right? So container A and container B. So let's start with A. In A, we're given 2.0 atmospheres and the volume is 10.0 liters. In B, the pressure is 4.0 atmospheres and it also has 10 liters. So for the temperature, they both have the same temperature.
What was that?
You want to convert them to Kelvin, giving us the initial temperature of 300.15 Kelvin and the final temperature for 100.15 Kelvin. Now we're looking for the new pressure of both containers after the stopper was released. Now let's compute or calculate first the pressure at each tank at 127 degrees Celsius or yeah, for 100.15 Kelvin. So you can see the volume of each container is 10, right? So now let's use the formula. For container A, 2.0 atmospheres over 300.15 Kelvin is equal to X, since we're looking for the pressure, final pressure, over 400.15 Kelvin. So this will give us X, or P2, is equal to 2.67 atmospheres. Now, for container B, 4 atmospheres over 300.15 is equal to Y over 400.15 Kelvin, right? So Y, which is the final pressure at container B, is equal to 5.33 atmospheres. Now, when the stopper is removed, the volume changes, right? So instead of having 10 each, the volume will now be 20. Now we have to use the Boyle's law.
Oh my God!
So now let's apply Boyle's law. Container A will give us 2.67 atmospheres times 10 liters is equal to X times 20 liters. So this will give us 1.33 atmospheres. For container B, 5.33 atmospheres times 10.0 liters is equal to Y times 20.0 liters. Calculating that, this will give us 2.67 atmospheres. Since the volumes of each container are combined, we have to combine the pressures too. So the final pressure will be 1.33 atmospheres plus 2.67 atmospheres. This will give us 4.00 atmospheres.
Wow, that was so powerful.
Okay,